Hi, I'd like to talk about our research, optimal intermittent deployment and sensor selection for environmental sensing with multi-robot tips. We are from Laboratory for Coordination at Scale, Virginia Tech. In this paper, we formulate an environmental sensing problem for multi-robot teams that couples intermittent deployment with the selection of team composition and sensor type. We suppose that a multi-robot team need to autonomously sense an environmental process and also need to find a good policy for deploying heterogeneous robot teams. By utilizing the structure result from POMDP and also exploring submodularity, we can say that we can achieve a good monotone policy. Let's look at it. The first question is why we need an intermittent deployment policy. Because the large body of the robotics research work is focused on the assumptions that an environment should be sensed. Our suggestion in this paper is that we should first ask ourselves when it is appropriate to deploy our robot. Specifically, we want to select a good policy, which can minimize the cost of deployment while maintaining a high sensing accuracy. Suppose if you want to sense a slowly evolving environmental process, a persistent sensing strategy is not a good choice, because the information you get between two consecutive observations may only be slightly changed. So we need a smart way to sense our environment. Our environment is a POMDP model, with S as the state space and A as the action space. The key idea of our paper is the submodular cost. We formulate 4 different costs: false alarm cost, delay cost, and also heterogeneous deployment cost and the robot sensor accuracy cost. If the following 4 assumptions are satisfied, we can say that we can get a good policy. Let's look at our result. This is the Monte Carlo simulation of our transition matrix. After we get our transition matrix, we can easily compute the intermittent deployment policy. The left-hand side is the optimal sampling policy, which is also the optimal intermittent deployment policy for our heterogeneous robot teams. The right-hand side is the comparison between our optimal policy and the myopia policy and the random policy. We can say that our optimal policy can always achieve the noise cost. Thanks.